I like big numbers. I always liked them. Even when I was young, I liked numbers. I remember when I was like 4 or 5 years old, when I just first learned multiplication and multiplication table. We were in our old house back then. Someone told me about a light year. A light year is the distance light travels in 1 year. Light travels 300,000 kilometers per second. So how many kilometers it travels in a year? So I took a fancy of it, and because I learned multiplication and I was very excited about multiplication, I thought, okay, I will find out what is a light year. So I started multiplying in a slate. I still didn't have pens and notebooks because I was not in school yet, but I had a slate and a pencil. So chalk actually. So I computed a light year on a slate, and I loved it. So my fascination with large numbers still continues. So these days, when I don't get a sleep, which is often, I think of large numbers. I mean, two types of large numbers. One is like simple type, like like 9 to the power 9 to the power 9. It's a insanely large number. I'll tell you exactly what I mean. I mean, although it looks simple, I mean, you can just write it down, 9 to the power 9 to the power 9. But it's very, very big. When I say big, what do we mean? I mean, it's bigger than any physical quantity in the universe. I mean, even you take like absurd quantities, like all the protons in the whole universe. I mean, there are billions of stars in our galaxy alone, and there are billions of galaxies in the universe. And I'm talking about protons, and there are billions of protons in a drop of water. So even if you take the total number of protons in the whole universe, it'll go like 10 to the power 60, 10 to the 70 max, right? This number, 9 to the power 9 to the power 9, is like incomparably, I mean, unbelievably bigger than even that number. So it has no physical significance. Now, that statement itself is a leap of faith. I'll explain what I mean. When I say it has no physical significance, we essentially trying to say is that everything physical can be described by mathematics, right? I mean, that numbers can describe the universe. That mathematics can describe the universe is a leap of faith. It's like believing in God, right? And believing in mathematics. There is no proof that it does. I mean, we can approximately make some predictions using mathematics, but that does not essentially means the whole physical world is described in the language of mathematics. We assume that. That's a belief. I have that belief. I am a believer in that sense. But anyway, coming back to my story. So the number 9 to the power 9 to the 1 9 has no physical significance. So where does it exist? If it's not there physically, where does it live? It lives in my head, right? It lives in everybody's head. So if I chop off everybody's head, it will disappear because it does not exist in the physical world. It only exists in our fancy, in our imagination. So if there is no head, if the earth somehow is destroyed by nuclear weapons, there will be no such number as 9 to the power 9 to the power 9. This by itself is a profound concept, that all these ideas of mathematics and the models of the universe that we build, that exist in our head, or does it exist somewhere else? I mean, that's a very interesting point. But okay, so that's about numbers that I try to ascribe physical significance. But then I think of another type of numbers, like very big numbers, like say Google or Googleplex. Now these numbers, this Google has nothing to do with the company Google. I mean, it predates much before. I think the Google company may have derived their names from this number. So a Google is 10 to the power 100. Now 10 to the power 100 again is insanely big number, which is bigger than any physical quantity you can think of. But it's still not big enough. My little pet number 9 to the power 9 to the power 9 is way much bigger than Google. So the guys who first thought about Google, they knew it. So they said, okay, let's get a bigger number, Googleplex, which is 10 to the power Google. So that's essentially 10 to the power 10 to the power 100. Now that is an insanely big number. Now, of course, they cannot have any physical significance. I already discussed that there is no physical meaning to any of this. But mathematically they exist. And now, when, as I said, when I and we as Indians, we always knew of big numbers when in the very beginning dawn of civilization. And the reason we could think of big numbers, I mean, we already know these numbers like lakhs and crores, and when I was young, we knew about numbers like Padma, Mahapadma, and those by itself is like bigger than billions and trillions and so on. In English now we have millions and billions and trillions and I don't know, septillions, quadrillions, whatever that is. Again, those are not so big, but big from a human point of view. So we Indians could think big numbers because we invented zero, and more importantly, we invented the positional notation of numbers. So for us, 1, 12, 1, 2 means 12. So the 1 there, because it's one step ahead of 2, has a significance, and it means 10, not 1. This thing escaped other people. And we Indians did it. I don't know what did the Greek do. I mean, I don't remember. But the Romans, for example, they were much crude, right? They could not think of positional notation. So for them to write, say, 352, they had to say C, and then what is, and then maybe X, and then 111. So 111 means 3, does not mean 101, right? So, and they don't write 1, they said I. So to write a Mahapadma, you will use the whole Italy to write it down. So they could not imagine such large numbers, but we could because we invented this positional notation. And maybe because I am an Indian, I take fancy of these numbers. So anyway, coming back to our story about Googleplex. So Googleplex is a very big number, right? So, but I am not satisfied with those. I mean, and there are other more complex big numbers. I mean, this arrow notation and stuff like that, right? If you go to Wikipedia, you will see. But I think of something better. I mean, as I said, when I don't get a sleep, I think of some crazy things. Like, for example, this factorial notation, right? N factorial. Factorial 5 means 1 times 2 times 3 times 3 up to 5. So if you put like 10 factorial, that by itself becomes like an extremely big number. So if you take, say, 100 factorial is gone. It's bigger than Google, I think. Yeah, it probably is. So I mean, so factorial makes a number very monstrous. So I take it like to extreme level, crank it up. So once I know n, for example, number n, say 5, I know 5 factorial. 5 factorial is 5 times 4, 20, times 3, 60, times 2 is 120. So factorial 5 is 120. Factorial 10 will be a very big number, but it's still a known number. So once you define n, you know n factorial. Now I define a function gn for any value of n. I say, what is gn? Gn is, since I know n, say n is, say, 100. So n factorial I will know, 100 factorial. So then I define gn to be as n factorial to the n factorial to the n factorial up to n factorial. So now you can understand how monstrously big does it getting. Now I don't stop there. I crank it up the wheel even further. So I say fn. Now I know gn, right? Once I define a fixed n, I know what gn is. I can now compute factorial gn. Now I'm saying fn is equal to factorial gn to the factorial gn to the factorial gn up to factorial gn times. Now if I plug in n equal to Googleplex, that number boggles your mind. I don't want to use the word cliche as boggles your mind. It literally does. If you rationally try to think about the number, you will go insane. So that's how monstrous these numbers can get, and then you can keep going. I mean, there's no end to it. Where I'm trying to get to is, and that is the scary part, is it is still all finite numbers for any finite value of n. Infinity is bigger than all these extraordinarily mind-bogglingly big numbers that you can think of and which has no physical significance. Just this simple number 979, I said, that has no physical meaning. So all these numbers are absolutely absurd and all are thought process. But infinity is bigger than any such finite number, no matter how big it is. So what does it mean? I mean, infinity by itself, infinity. So I mean, even if that number I talked about, f Googleplex is a very big number, I can still add 1 to it and I get a bigger number. So it does not stop. So what is infinity then? I mean, infinity is something that does not stop. For example, these numbers, I mean, natural numbers, 1, 2, 3, 4, 5, 6. If you keep on counting, you don't stop. You keep on going. No matter where you stop, you can just add 1 to it and you get a bigger number. So infinity seems to be like the approaching something that is bigger than anything else, right? And now this infinity of numbers is a baby infinity. It's a manageable infinity, I call it. They call it countable infinity, right? So why? Because there are infinities bigger than the infinity, which is like, again, completely absurd. This infinity of real numbers, and we can prove that. It's already proved by Gregory Cantor that infinity of real numbers is bigger than the infinity of numbers. And it doesn't stop there. We can keep on making bigger and bigger infinities up to infinite times. So I can make a set which is bigger than the set of real numbers, and then a set bigger than that, and so on. It doesn't stop. So all these things are really mind-boggling. I mean, you just go insane, and Cantor himself went insane thinking about all this stuff. But what I want to talk about is the following: that of course my little number 9 to the power 9 has no physical significance. So what does it mean with all these discussions, all these fanciful mathematical discussions about infinity and big numbers and so on? Infinity exists in real world. That is the funny part. So there is singularity. If you read Schwarzschild equations, Reichenbach equations, there is infinity in reality. You will approach a singularity, and that's a real thing, not fanciful thing. Real object in the universe which embodies infinity inside it. So therein lies the contradiction, isn't it? I mean, we cannot think of numbers bigger than 9 to the power 9 to the power 9 having any physical significance. Here we have a infinity which is there. And it's not just that baby infinity of the numbers. It is the bigger infinity of the real numbers. The singularity that exists in real world. So how do we square these ideas? I mean, and the fanciful part is the following: that the universe that we think of, we normally think in terms of numbers, right? Everything boils down to something discrete, protons. I mean, you cannot keep breaking things up to infinity and keep on dividing. In mathematics, you can do that, but in physical world, after a while, you come to a quanta that is unbreakable, and everybody agrees that, of course, matter is unbreakable. After you go to proton, maybe you can break into proton to quarks, but at some point, you cannot break it any further. And people think time and space are similar quantized. It's discrete objects. So that means it's numbers. So if we encounter infinity, it should ideally be the infinity of the baby infinity of numbers. But it's not. In the singularity, Schwarzschild singularity and other singularities that prop up in physics, it is the infinity of the real numbers. So it's just a little bit absurd that where does it lead to? All these thoughts about numbers. Of course, by the time probably I fall asleep and I don't get to the bottom of it. And these days I'm reading again, gone back to studying general relativity, and I do want to get to the bottom of that singularity. And I want to see what it means to have infinity in our system. Let's see where it leads. Thanks for watching.